All right, for the no fives activity, cannot stress this enough, at most 6 groups. So if you're someone that's sitting there by yourself as the 7th group, you've got to join a different group. I only have 6 bags of dice for this. Your first step is to collect the data. You are going to count the number of dice that are in your bag to start. That will be your first data point. You're going to put the dice back into the bag and you're going to shake it. You don't want to know what you're going to get. You're just shaking it up. You want it to be random. You're going to dump them all out on the table and roll them, right? So as I'm dumping them out on the table, they should be rolling, right? I'm rolling a giant group of dice. I'm going to see how many 5s I get, right? So maybe I started with 30 dice. I don't know how many you have. Maybe I'll just make that number super large, 100. Let's say I roll out the entire bag, I go through all the dice, and I only find, let's say, 15 that are 5s. I'm going to take those 5s and I'm going to put them off to the side. Those do not go back in the bag. And I record 1 roll. I got rid of 15, so I have 85 left. I'm going to continue to do that until I don't have any more dice left. So I take the 85 that I have left, I put them back in the bag, I shake them up, I roll again, and this time I got 20 of them. So now I have 65 left. I take my bag, I shake them up, I do it again, and I keep doing that as many times as I can, as many times as it takes me. If it takes you over 29, and maybe you just have like 1 left and you're stuck on it, then just stay stuck on it. It's okay. If you don't get rid of all of it, it's okay. It's not the end of the world. After that, you're going to take your table and put it into Desmos. Be careful. Let's just say, and I'll continue this, 100, 85, 65, we'll say 50, 40, 35, and I go on and on and on. 25, well, that's 3, 25, 20, 18, 16, let's say 16, we don't get any, 14, 12, and then let's just say magically those are all 5s and I have 0. The table I'm putting into Desmos, 0 through 13, and then all of these outputs. Okay, so just make sure you're not separating these into 3 different tables. They're not 3 different tables. Make them 1 long table. From there, whatever you get from your data should match what your group gets. The first thing that I want you to do is analyze. Do you think that those data points look linear, quadratic, or exponential? Graph it, click the magnifying glass, and see what you think they are. Use Desmos to determine the regression equation. You're going to run a linear regression using that equation, quadratic regression using that equation, exponential regression using that equation. You are going to look at what the r and r squared values mean. These will be smaller numbers, less than 1. So hypothetical data here. Say that's 0.6, 0.8, and 0.95. Again, purely hypothetical. If your data looks like this, and you're trying to figure out which one models your data the best, you are looking for the r or r squared value that is closest to 1. The closer you are to 1 or negative 1, sorry, I forgot to point that out. These could all be negative, right? So that could be negative 0.6, negative 0.8, negative 0.95. The closer you are to 1 or negative 1, the stronger the relationship. That's something that we looked at way back last semester. So in this case, I would say, hey, well, that exponential regression was definitely close to 1, so that was the strongest relationship, so I'd probably say that this is exponential. You could say it looks exponential, and you could explain why, right? You could talk a little bit about the graph that you end up getting in Desmos. And then you can talk about why the data is linear, quadratic, or exponential based on your answers here. So you can look at the table, you can look at the graph, you can look at your R values here to give some reasoning there for D. For example 2, you are running through these 5 different problems, and one might be linear, one might be exponential. You're trying to figure out which one best represents it, right? Remember, if it is a constant rate of change, so adding or subtracting something every single time, that's linear. If it is a multiplication or a division, like it's doubling or halving, so taking half, this would be exponential. The one thing that I'll look at in this case, I'm looking at this example here where it says it's tripled. Well, that's 3 times the amount. Not telling you what it is, just hopefully helping you out. Decide whether it's linear or exponential, provide the correct equation based on that. And that is it. Work together as a team. I should not hear of anyone that was just leading the discussion and everyone was just following along. Please turn these in by the end of class. The sub will collect them.